I told you a shortcut how to convert everything into electron volts.
हाँ.
Okay, let's start the practice. I'll just open the whiteboard. I think I've not opened it. No.
No.
Yeah. Okay. Use calculator.
अच्छा.
Okay. First question. 3 mark. Okay. This is called mu naught, threshold frequency.
हाँ वो फ्रीक्वेंसी नहीं है.
जो यहाँ पे लिखती है ना ये.
हाँ वही.
This is h nu naught.
ओके.
वर्क फंक्शन तो ऐसे कैलकुलेट होगा ना,
अच्छा.
जो जिससे वो थ्रेशोल्ड कन्वर्ट हो जाएगा, एच न्यू निकालोगे.
हम्म. तो विल फोटो एमिशन अकर से होगा क्योंकि वो थ्रेशोल्ड फ्रीक्वेंसी से ज्यादा ही है.
ज्यादा है. यस, यू कैन से दैट. ओके, यस, आंसर इज यस.
या.
रीजन आपने लिख दिया. ओके, ठीक है. अगला, कैलकुलेट द एनर्जी ऑफ द फोटोन, एच न्यू.
या. हाँ.
राइट. इफ
या.
फोटो एमिशन एकर्स, कैलकुलेट द काइनेटिक एनर्जी. आ जाएगी.
हाँ.
कन्वर्ट करना शॉर्ट ट्रिक्स है. कैन यू कन्वर्ट दिस फ्रीक्वेंसी इनटू एच न्यू इनटू द इलेक्ट्रॉन वोल्ट्स फर्स्ट? एच न्यू को किसी भी एक को देखो, कर पाते हो जल्दी जल्दी?
1240 वाला लैम्डा से.
वो तो लैम्डा है.
हाँ.
यहाँ तो फ्रीक्वेंसी दी है ना, तो या तो इस फ्रीक्वेंसी को वेवलेंथ में कन्वर्ट कर लो और फिर
अच्छा.
नैनोमीटर लेके आओ. है ना, यहाँ फ्रीक्वेंसी लैम्डा तो है, दिया नहीं. लैम्डा इंटू सी.
हाँ.
लैम्डा इंटू फ्रीक्वेंसी इज इक्वल टू सी.
सी. या.
लैम्डा की जगह लिख लो सी बाय एफ.
अच्छा.
और आपको पता है लैम्डा इज इन नैनोमीटर, तो नैनो ये तो आपने मीटर में कर दिया सारा,
हम्म.
तो नैनोमीटर में होना चाहिए अपने.
तो
नैनोमीटर्स होते हैं ये, तो
टू
कन्वर्ट.
10
नीचे है लैम्डा, याद रखना. ऊपर आएगा नीचे आएगा.
नीचे ही आएगा.
ओके. नैनोमीटर को नैनोमीटर में कन्वर्ट करेंगे तो 10⁻⁻⁹ से मल्टीप्लाई होगा. 1 मीटर.
हाँ वो तो ठीक है. नहीं, लेकिन जैसे जब हम कर रहे होते तो लाइक लैम्डा दिया होता है जब, तब तो नीचे लिखते हैं -9।
लैम्डा नीचे रखते हैं ना।
हाँ।
एक मिनट में करके देखता हूँ मुझे। सो यू हैव फॉर एग्जांपल दीज मेनी लैम्डा। आपका जो लैम्डा है, मैं देख रहा हूँ लैम्डा आपका कितना है, बेसिकली 3 × 10⁻⁸ 6 × 10⁻14 meters, right?
या
This is a lambda.
या
Now this is in meters. So 1 meter is equal to 10⁻⁹ nanometers. कितने होते हैं इसमें नैनोमीटर? सॉरी,
9 होता है।
9 ही होते हैं।
हाँ।
ठीक है, नैनोमीटर, राइट। सो इतने अगर हमारे पास होंगे
हम्म।
मीटर्स, तो कितने नैनोमीटर हो गए हमारे पास? इतने हो गए ना नैनोमीटर्स।
हाँ।
ये 3 हो जाएगा।
हम्म।
ये 2 आ जाएगा। ये बन गया 500 इलेक्ट्रॉन वोल्ट्स। सॉरी, ये तो नैनोमीटर आ गए, सॉरी, नैनोमीटर्स। उसको हम डाल देंगे यहाँ पे। तो यस, इंटू 10⁻⁹ से ही मल्टीप्लाई करना है नीचे।
ठीक है। नीचे।
उल्टा
अच्छा।
है ना, मतलब आप बड़े
हाँ।
यूनिट को छोटे में कन्वर्ट कर रहे हो। 1 मीटर को अगर सेंटीमीटर में कन्वर्ट करेंगे तो 10⁻² सेंटीमीटर
हाँ।
लिखोगे
हाँ,
या
बड़ा है।
10⁻⁻² लिखोगे?
नहीं नहीं, 2 लिखेंगे।
छोटे में कन्वर्ट कर रहे हो ना।
हम्म।
आगे समझ?
हाँ हाँ।
ओके, सिंपल था ये। बेसिक, बिल्कुल बेसिक टाइप का क्वेश्चन है। ओके, जस्ट फॉर्मूला।
हाँ। हम्म।
ओके, वन कॉन्सेप्ट विच वी हैव नॉट स्टडीड, लेट अस स्टडी इट। ओके,
अच्छा।
just give me 1 second, only 1 second. So this concept is called as stopping potential.
स्टॉपिंग
Okay?
पोटेंशियल। ओके।
Stopping potential. But it's very simple. मैं आपको थोड़ा समझा देता हूँ what it means. So जो भी इलेक्ट्रॉन बाहर आता है, right? The electrons come out, and the electrons then are, so there is a photon which strikes a plate,
हम्म।
metallic, and the electrons come out, right? So these electrons are attracted by they can be attracted by a positive plate. They have kinetic energy, right?
हाँ।
So it's a positive plate, it will attract. Instead, what they do is they put a negative plate.
अच्छा।
So what negative plate does is repel it. It does work on this. So this electric field,
ओके।
which is
हम्म।
because of the negative plate, it
हाँ।
does work on the electron and repels it. तो सारी की सारी जो इलेक्ट्रॉन की एनर्जी मिली होती है
या।
because of emission now gets utilized in overcoming this force coming from the negative side. So
हम्म।
all of this becomes half mv square becomes equal to EV, where V is the potential difference through which it travels. मान लो there is a potential here and some potential here. V is the potential difference here.
हाँ।
So, so this basically is what you had when you left the photo emission material. This material you got
अच्छा।
emitted because of the photon.
या।
You got emitted, and now you will start moving with some kinetic energy, which is this. But because you
हम्म।
have a potential which is repelling type, you will
हाँ।
not be able to reach that point, and you will lose all your energy, which is half mv square is equal to EV. So the work done by the electric field here, obviously the electric field be like this only,
यस।
positive to negative, will stop you completely. So
ओके।
when you give this electron h nu, some part of it obviously is utilized here in the work function,
हम्म।
but the balance, we write it like this, right? Now, a lot of scientists want to measure how much is this.
हम्म।
right? They can't just by observation measure it. So they
Yeah.
put it in an apparatus where they can keep on changing the potential. And then at the potential where the electron has no velocity, which means this is cancelled by EV. They read the value of V, potential difference, where there is no kinetic energy. They know the charge on the electron, they know mass of the electron, they're able to find the. So half mv square is equal to EV, and
अच्छा.
V square is equal to 2 EV by ME. So V is equal to under root of 2 EV by ME. So the velocity which
Hmm.
the electron had when it entered becomes zero because somebody else has done work on it. It's like some brake is working on a car. Car has a kinetic energy,
Yeah.
you're applying brake on it. So that
Okay.
frictional work
हाँ.
completely takes away your kinetic energy and you stop.
अच्छा. Okay. Okay. Yes.
To put in
Yeah.
this here, if you put positive plate, it will start accelerating. Then you can't know what exactly was the velocity. You're further adding positive work to it. So you add negative work to it. So you are at 2 joules of positive energy, kinetic energy, and you add minus 2 joule to it. You make it zero.
अच्छा.
But you use electrostatic potential to make it zero because it's a charged particle. So
Hmm.
in the photoelectric effect, you can also write half mv square is equal to E stopping potential, which means the total energy is equal to 5 plus EV stopping. So this whole thing is done to measure the velocity of the electron when it got ejected from the surface.
Yeah.
Clear? So this
हाँ.
is called
Clear.
the concept of stopping potential. It is just a way to measure the velocity by completely stopping the electron with the help of electrostatic potential.
हाँ. ठीक है.
Calculate the energy of the photon. So that shortcut is to be applied now, right? Because he's asking 1240 by nanometer. This is given in
हाँ.
nanometer.
Yeah.
So you could have done it in a one line.
बी वाले पार्ट के लिए फ्रीक्वेंसी निकालनी है।
मतलब if you know that the energy of the photon is
हाँ।
greater than the work function,
यस।
then the
देन।
emission will happen.
यस।
कहाँ लिखा है थ्रेशोल्ड निकालो? या तो इससे थ्रेशोल्ड निकाल लो उल्टा कैलकुलेट करके,
हाँ।
राइट? या
या।
इसकी एनर्जी निकाल के कंपेयर कर लो कि इतनी एनर्जी है मेरे पास। अगर एनर्जी आपकी 4 आ गई
हम्म।
तो निकाल लोगे, एमिशन
अच्छा।
हो जाएगी।
ये हाँ। अच्छा।
क्वेश्चन इज नॉट कंपैरिजन ऑफ फ्रीक्वेंसीज है, क्वेश्चन इज कंपैरिजन ऑफ एनर्जी।
यस।
अनलेस वो दे दे कि जो ये मेरा जो है ये वेवलेंथ
हम्म।
है ना, वो इसके साथ मैच करती है कि नहीं करती है, इससे जो फ्रीक्वेंसी आती है।
हम्म।
आप इससे भी फ्रीक्वेंसी निकाल सकते हो ना, इसी इसी कैलकुलेशन से लैम्डा आ जाएगा,
हाँ।
इससे लैम्डा आ जाएगा।
हाँ।
तो लैम्डा निकाल लो राइट साइड पे, या ऐसे कर लो जैसे आप कर रहे हो, उल्टा भी कर सकते हो।
अच्छा। ठीक है।
कन्वर्ट लैम्डा इनटू एनर्जी,
या।
डूइंग दैट, convert energy into lambda using the same formula. Find this lambda, but
अच्छा।
take energy as 2.5, and then उस lambda का frequency क्या है वो निकाल लो।
नहीं, फिर तो लाइक ज्यादा लंबा
या
हो
चेक
गया।
कर लो कि इससे जो lambda आता है,
हाँ।
अगर lambda इसका बड़ा आ गया
अच्छा।
इससे, तो इसकी फ्रीक्वेंसी छोटी हो गई ना फिर,
हाँ।
थ्रेशोल्ड तो नहीं होगा।
ठीक है।
अगर आपके दिमाग में लगता है कि भाई थ्रेशोल्ड फ्रीक्वेंसी आई अंडरस्टैंड बेटर, देन डू इट दैट वे।
नहीं नहीं, ठीक है। ये वाली लाइक जो एनर्जी है फोटॉन्स की, वो ज्यादा आ रही है।
हाँ,
देन होगा।
राइट। आपको मिनिमम जो चाहिए मिल रहा है ना आपको,
यस।
250 तो ऊपर चले गए हो, यू आर अबव
यस।
दैट, राइट?
हाँ। सर, जो इसी क्वेश्चन का थर्ड वाला है, एक बार वो बता दो।
डाउट क्या है, कॉन्सेप्ट तो आपको आता है। What principle determines govern these changes?
नहीं नहीं, इससे पहले वाला, स्टॉपिंग पोटेंशियल।
Okay. हाँ, it is equal to the kinetic energy. भाई अगर आपने 3.1 मारा इसके ऊपर,
हाँ।
तो आपका खर्चा कितना होगा? वर्क फंक्शन, ठीक है?
अच्छा।
नहीं
हाँ।
समझ आया? अच्छा मतलब
नहीं,
क्लियर है या नहीं समझ आया?
थोड़ा नहीं आ रहा
वो
ढंग
तो
से।
अच्छा का क्या मतलब हुआ? यू से आई डिडंट अंडरस्टैंड इट। So that means you're giving a photon of energy 3.1 electron volt,
या।
out of which 2.5 electron volt will be used to take the electron out.
टर्न्स आउट, यस।
The balance will be used as kinetic energy,
ओके ओके। ठीक है।
right? So the balance is how much?
0.6।
Is equal to EV,
या।
stopping, answer.
ओके। ठीक है। या।
Next. अच्छा का मतलब मुझे समझ में आया कि समझ नहीं आया, कोड वर्ड है ये। ठीक है, दिस इज फर्स्ट टाइम यू डूइंग इट, सो इट इज ओके, बट डोंट बी शाई।
the number of photo electrons get doubled।
Yes. Yes, yeah, because one photon can, and if you're above the threshold frequency, then
Yeah.
the more photons you will give, more photoelectrons you will get.
Yeah. The kinetic energy does not change.
Yeah. Cannot.
Yeah. What principle? Photoelectric.
What principle has been used here, right? Matlab, it's answering which principles? Yeah, yeah, photoelectric. Correct. Any doubt here? Please
No.
don't feel free to say, I have not understood. It's okay. That is why you are here. I hope you studied this topic, revised it thoroughly.
Yeah, I did.
Okay. Any doubt you have? समझ में आ रहा है ना?
Not in.
थ्रेशोल्ड फ्रीक्वेंसी से निकलती है थ्रेशोल्ड वेवलेंथ भाई लैम्डा जो आता है हमारे फॉर्मूले में नीचे जो लैम्डा होता है बट यू हैव टू यूज द ये स्टॉपिंग सॉरी you know that calculate the threshold wavelength okay
Yeah.
so mono calculate the work function okay अच्छा this wavelength produces a stopping potential on a metal surface so a mono light source produces a stopping okay so इन दोनों का डिफरेंस आ जाता है ना इससे this is the हाँ ठीक है this we know so you calculated 4 okay
Yeah.
बढ़िया so you know 5 5 I guess
Yeah.
so the work function okay great work function is known to you. Okay, done. Now use this in this formula again and get the lambda threshold. E is equal to 1240 by lambda. But use this as a E now because your new energy is this.
Yeah.
To calculate the threshold, you use work function.
Yeah.
What was the decision in the school? Have they decided to open the
Open
hybrid
schools. नहीं open. No
अच्छा,
hybrid.
एग्जाम गए
नहीं हो रहे.
हैं? हो रहे हैं?
हाँ.
कैलकुलेट 600 नहीं 6 5.9 नहीं आएगा ये
5
नैनोमीटर्स में आएगा
something.
you will get the answer in nanometer can you use calculator
It's
can be 6 also 6 2s are 12 roughly 5.95 I think but you can
582 आ रहा है.
कितना how much
582. 582.
nanometer okay
Yeah.
excellent so you've calculated the threshold wavelength
Hmm.
good very basic but still they help you understand it
Yeah.
डिटरमिन द मोमेंटम ऑफ द फोटोन, बताओ मोमेंटम कैसे निकालोगे? आई थिंक ये डी ब्रॉगली के ऊपर तो नहीं पूछ लिया इसने।
तो पहले स्टॉपिंग पोटेंशियल निकालेंगे।
एनर्जी एंड मोमेंटम ऑफ अ फोटोन, इवन एच, कैलकुलेट द एनर्जी, डिटरमिन द मोमेंटम ऑफ द फोटोन। नहीं, अभी नहीं निकाल पाओगे, अब बी छोड़ दो। ये हमने डी ब्रॉगली नहीं पढ़ा ना, बी बी छोड़ दो।
अच्छा, ठीक है।
सी तो बिल्कुल इजी है।
यस।
If you convert the answer into electron volts, if it is greater than 2 electron volt, answer is yes. मतलब वर्क फंक्शन को बीट कर दिया ना।
हाँ।
जो आता हो कॉन्फिडेंट हो उसको फिर नहीं करना, देख पढ़ लेना, लेकिन okay.
ओके।
अभी वी आर डूइंग बेसिक्स सो दैट यू हैव क्लैरिटी। इंटरनेट को बढ़ा दिया मतलब फ्रिक्वेंसी कम कर दी है।
ओ हाँ, तो नहीं होगा।
ठीक है, गुड है। इस तरह के क्वेश्चन आते हैं, मैंने देखा है। जस्ट लास्ट न्यूमेरिकल एंड
ओके।
देन वी विल डू ग्राफ्स।
सब मेटल ए में। तो बी और सी में नहीं होगा फोटो एमिशन।
निकाल ली वैल्यूज।
2.7
कितना आया वैल्यू ऑफ द जो स्ट्राइकिंग फोटोन है उसकी कितनी आई है ये?
और 2.7।
सो 2.7। ओके, तो ये तो गया। ठीक है,
हाँ,
बी एंड सी।
नहीं होगा।
हाँ, नहीं होगा क्योंकि वो हायर है। ठीक है, रैंक द मेटल बेस्ड ऑन द काइनेटिक एनर्जी। ओके, maximum kinetic energy of the emitted electrons. Yeah, मतलब for the same photon. अच्छा, if the threshold frequency is maybe having energy of 5 electron volts, for example, इसमें पूरा नहीं दिया कुछ। मान लो कि एक फोटोन तीनों के ऊपर पड़ता है जिसकी एनर्जी 5 है,
या
then maximum kinetic energy will be in the case of first
सी।
because उसका working stopping potential, sorry, the work function is the smallest, so kinetic energy is the highest.
अच्छा, या
5
फर्स्ट।
minus 2, 3 is the balance, right? So you have
या
ample energy.
यस यस, ठीक है।
Next. Okay. Cutoff means same as threshold.
अच्छा
So you can find the threshold for this answer.
अच्छा, वही 1240 बाई
That's all. Very same.
ठीक।
Repetitive. Nothing great about this. Okay. Let's do the graphs now.
या
So I'll go to the next page and we will do the graphs. Four graphs are there,
ओके।
which we have to understand. A lot of questions are graphical in this. It's part of, I don't think so. Lawrence. Oh, okay. So just give me 1 second. Let me just find the first graph. So all the ideas we have studied can also become graphs. Equation can be made in the form of a graph. Okay. Okay. Strange. Up there. अरे एक ढंग का ग्राफ बना दो. Okay. So I'm starting with simple graphs,
Yeah.
which are very self-explanatory. You have to memorize this and also understand what they represent. Let me give you a graph here. Okay, so see the graph. Tell me, what does it tell you? So the y-axis is the photoelectric current, which is the electrons which have come out. Okay,
Yeah.
so this is your photoelectric current.
Mm.
Photoelectric current, and this is intensity, which is a number of photons. So you can see after the threshold, obviously, you can see the current. So
Yeah.
here, the intensity is zero, no photon is striking, so no
Yeah.
current.
Mm.
But when the intensity, the number of photons are increasing, the
Yeah.
number of electrons will also increase. So
Yeah.
you can see the current rising. So the relationship between them is directly proportional, hence a straight line. So if you're noticing the current because of the photoelectric electrons, photoelectrons, this is the way it will look like. This is photo current.
Yeah.
This is the
Yes.
intensity, which is the photons striking the surface. So you are striking the surface.
Mm.
Millions of electrons are coming out, becoming a current, stream of electrons. Maybe you have a positive plate here. So the electrons
Mm.
start moving straight like a current. So you will notice if you have a galvanometer here, this side somewhere, you will see the
Mm.
reading is coming out to be higher.
Okay.
As the intensity increases, number of photons increases, more
Mm.
electrons come out, so more reading.
Mm.
To make them a current, a positive plate has been introduced.
Yes. Right.
Second, so what is the relationship between the stopping potential? Okay, let's see what is happening in this graph. So every graph has a story behind it. You should know that
Mm.
which graph is what and what is a story it tells you. Okay, look at this. Note. So this is stopping potential.
Yes.
This is the potential of anode, and this is the current being noticed. So if you apply a stopping potential, obviously your current will become zero, right? If,
Yeah.
if the
Yes.
potential becomes equal to stopping potential, it's a break. So
Yeah.
if you touch stopping potential, you will stop whole current. So you can see on the left-hand side,
Mm.
because of there is negative plate, no electron is there, no current.
Yes.
It abruptly stops at here.
Mm. Yeah.
Right? And what is happening is if you increase the potential, which is like positive plate to attract the electron, you will be able to attract all the electrons. The current will saturate. The current will become maximum current. That's all. So as you start increasing the potential,
Mm.
only few electrons are attracted. Once you make it bigger, more electrons get attracted, more electrons, and then finally all the 100% electrons. So you can see the current has become saturated, which means constant in this range, almost.
Yeah.
Because you're able to attract all the electron towards the plate. So if the 100 are there, all 100 are reaching. Beyond that, you don't have electrons. So finally, the saturation current appears.
ठीक है.
Okay, now what have you done? Now you have intensity is lower. You are putting less number of photons on the metallic surface. So less electrons come.
Yes.
But if you apply the positive potential, same behavior because you have
Mm.
less number of photons and therefore your
Yeah.
saturation current is low. Now 80 electrons were emitted and 80 are reaching.
Yes.
So obviously The shape of the graph is same. The intensity is the distinction. So if they just give you this graph and they say, what does this graph mean? You should be able to make them understand that there is in the negative side, there is no current actually, because you're trying to stop the electrons.
Yes.
But do you know that the current is not zero at zero potential? It has a value.
Oh, हाँ, yeah,
You see
yeah.
the potential is zero, but there is still a current. Current has not become zero. If you increase the negative potential, now you take it towards negative side, finally the current will become zero, because if finally the stopping potential, depending on the scenario, will decide and completely takes away the kinetic energy. So maybe for some situation, this is the stopping potential, and you will realize that the current becomes zero here.
अच्छा, like zero पे zero नहीं है, it's zero at stopping potential.
Yes, obviously stopping. What is the meaning of the word stopping?
Not to stop, yes.
Stops.
Yeah.
So for example, you applied this much potential, right? So still you have consumed some amount of kinetic energy of the electron, but still something is left,
अच्छा,
right?
yeah,
But
yeah.
if you further make it negative, your potential, you will reduce the kinetic energy of the electron further and further and further, right? So the current which is being observed, because electron is not able to reach, lesser number of electrons will reach, and finally at the stopping potential, no electron will reach.
Okay.
Okay.
ठीक है. Yeah, yeah, yeah.
Okay.
Understood.
Next. Next graph. Let's see this. Now he is drawing a graph again of saturation current versus potential, but now he is not using intensity to show the difference. He has made the frequencies as separate. So if you have a higher frequency, the kinetic energy of the electron emitted is high because work function is the same. If you have higher frequency, the kinetic energy will be higher.
Yes.
We know that already, it's directly
Yeah.
proportional.
Hmm.
So if the kinetic energy is high, the stopping potential will be higher. Difficult to stop.
Yes.
So you can see the if
अच्छा, yeah,
is
right.
bigger,
ठीक
so
है.
the stopping
Yes.
potential is also difficult. This actually shows you the diagram of same thing, saturation current and potential, but at two different frequencies.
Yeah. ठीक है. Understood.
Okay, now the next graph. Tell me, what does it tell you? Are you able to make some sense from it? See. This is obviously the stopping potential, Vs. And on the x-axis, what you have is the frequency. So this is mu. This is frequency. Mu naught. What you see as V, this is actually mu naught. Nu naught, which is the threshold frequency. And then the frequency has been increased beyond the threshold. So you can see if you have a threshold frequency only,
Yeah.
then the electron will come out with no kinetic energy.
हाँ.
Because your energy is just sufficient to take
Yes.
out the electron, right?
Yeah.
Your electron has no kinetic energy.
Yes.
So you don't need any threshold voltage to stop it. You don't need, stopping potential. You
Right.
can see at this frequency, the stopping potential is zero.
हाँ.
But as the photon energy keeps on increasing for this metal, the kinetic energy increases, and therefore the stopping potential is also increasing.
Yes.
So basically, what it is telling you, that the
Frequency increase है तो stopping.
exactly. So it's a linear relationship because this is your applied energy, phi naught plus EV, right?
Yeah.
So higher frequency results in higher stopping potential.
Yeah.
This is what it tells you. This has been plotted on y-axis. This has been plotted on x-axis.
Yes.
Higher frequency will
Hmm.
result in higher kinetic energy and a higher stopping potential.
Hmm.
सही है?
Yeah.
Okay. Next. Okay. Now what we study is the concept of de Broglie wavelength. So please memorize all these graphs.
Right. Yes.
Okay?
ठीक
You
है.
have to memorize. They're written
Hmm.
everywhere. All
Yeah.
books, everything, NCERT, everywhere.
ठीक है.
Just memorize them because this question is bound to come. One graphical question.
Hmm. ठीक है.
Okay, let's do de Broglie, right? Okay, so far what we did was we did photoelectric effect. What was the application of photoelectric effect? When which principle did it tell you that the light radiation is also a particle?
Yeah.
Radiation is a particle.
Yes.
Radiation is a wave was known. Radiation is a particle was proven by this
Hmm.
photoelectric effect
Yeah.
conducted by Hertz, and the
Hmm.
maths of it or the logic was given by Einstein.
Hmm.
Now we will study matter, but we will say matter is just not particle or matter, it is also a wave. Okay.
अच्छा.
So the
Yeah.
scientist who explained everyone the
Hmm.
concept of matter as a wave was D.E. Broglie.
अच्छा. Yeah.
Matter as a wave,
Hmm.
which means your bus, your laptop, everything has a wave also.
Yeah.
Wave, which is very weird. But
Hmm.
this is
Yes.
studied in the context mainly of the subatomic particles like electron, proton, very small. Generally, we don't
Hmm.
study it for very large particles because the wavelength is not visible in that case. The wave behavior cannot be noticed. In subatomic particles, it is noticeable. Okay. So
Hmm.
D. Broglie gave a concept if you have a particle of mass m
Hmm.
moving with a velocity of v, then the wavelength of the particle will be given by Planck constant divided by m into v, the momentum of the particle. I will just paste it so that you can see it also. Read it. So it is not photon which exhibits both the behaviors. The matter also exhibits both the behaviors. We are studying the particle nature, wave nature of the matter. So this is the P. P is equal to m into v, momentum.
Momentum.
Understand?
Yeah.
Clear?
Yeah.
Simple, right? Good. There is
Yes.
nothing great about it. Okay, what are the implications? Okay, so you are able to make sense of, for example, diffraction we studied when monochromatic light is passed through single slit.
Hmm.
Right? We get a diffraction pattern and fringes on both the sides. If
Yeah.
you send electrons also through a slit, the
Hmm.
electrons also show a diffraction pattern. They are sent through a crystal actually, right? But
Okay.
uh, so you only knew that the diffraction is produced by waves, radiation, sorry,
Yeah.
which is waves. But
Hmm.
now even electron, which is a particle, is showing you the same behavior. So
Hmm.
matter is behaving like waves because it is showing
Yes.
you diffraction.
Hmm.
So
ठीक
what
है.
are the implications of this theory? So you can see that particles like electron, even larger objects, exhibit wave-like properties under certain conditions. They could
Hmm.
explain the wave nature of
Yes.
electron with the help of
Hmm.
this
Yes.
model. Somebody said I can do a diffraction experiment. They said we know
Hmm.
particles behave like waves because
Hmm.
E. Logly has told us.
Actually,
And then
yeah.
you can see, right, the particles which
Hmm.
are
Yes.
quantum, which means subatomic,
Hmm.
wave properties are noticeable. But for car, tennis ball, it is so small that it becomes negligible. That is, if you put the mass of car here and the velocity of the car here, on momentum will be very small. So
Oh, yeah.
wavelength which you, sorry, momentum is very high.
Very, very large.
Wavelength which you get is so small that you
Hmm.
can't measure it. But if you use the speed of an electron, mass of the electron, this is very
Yeah.
small. So you do get some wavelength.
Okay. ठीक है. Yeah.
Very small topic, but okay. Now some MCQs on D broadly.
Hmm. See, it's momentum.
Okay. So this will help you just understand what is what. Get you
Hmm.
friendly with the formula. This I've already told you, so you know. ये एप्लीकेशन है बेसिकली रियल लाइफ होती भी है जो इलेक्ट्रॉन माइक्रोस्कोप्स होते हैं दे यूज दिस आइडिया यानी
Demonstrate.
द वेव नेचर ऑफ पार्टिकल ऑफ पार्टिकल और मैटर वन एंड द सेम थिंग
Electron diffraction.
और द नेक्स्ट क्वेश्चन इज वेरी इंटरेस्टिंग एंड
अच्छा.
विच मींस यू शुड नो 11th स्टैंडर्ड थोड़ी सी 11th स्टैंडर्ड आनी चाहिए you know it well you can easily solve it it's a bit hidden
Uh, so 1 by root k b
solve करो
x. फिर तो मोमेंटम का फॉर्मूला होता है ना, रूट में 2 × m × k.
हाँ so kinetic energy is given by half mv square right
Yeah.
so either you can find
mv.
velocity from here
Yeah.
velocity will be equal to under root of 2 ke by n,
हाँ, yes.
right? So
Yeah.
the wavelength is equal to h by mv, right?
Yes.
So this will become h upon under root of 2 ke divided by root n, and this is also 1 m, right?
Hmm.
Finally, I will divide, right? This is 2 ke by root n. This is the only velocity I've written. So I will write multiply by m also. These will get cancelled. So you will get under root 2 ke under root n. So lambda is inversely proportional to the kinetic energy.
Hmm.
The formula you were saying, kinetic
mv
energy can also be written
dt.
as half mv squared,
हाँ.
multiply and divide by n,
Yes.
right? So kinetic energy will become equal to p square by 2m.
हाँ. Yeah.
P square is equal to 2m
2m.
ke
Okay.
and p is equal to under root of 2m ke,
Yeah.
which is what we also got,
Hmm.
divided by momentum.
So fail to load.
fail to load.
Yes.
Let me go to the next page और गोरे जाके जाके there you go. देखो अब आया.
हाँ. Okay. C.
Yeah.
Mass is extremely small.
इलेक्ट्रॉन वगैरह के लिए, राइट सर.
Hmm.
Don't know this concept called Crompton effect. Okay.
Hmm.
पहले course में we had Davison-Germer experiment also, which was
अच्छा.
conducted to prove this model,
हाँ.
but now it is not in course.
It is half.
Yes, inversely proportional.
Yeah.
सही है.
So A. Electron.
One of the question, okay, which of the following is the largest? You calculated it. अच्छा, because it is a light text.
हाँ. Yeah.
या ठीक है. हाँ, करने की क्या जरूरत है, ये तो
गए.
बहुत मोमेंटम बहुत ज्यादा हो जाएगा इसका. मास भी है लेकिन इसकी वेलोसिटी है, लेकिन चार्ज इसका मास बहुत कम होता है ना,
हाँ.
-13 है.
वही.
हाउ विल यू बीट? मोमेंटम इज बाउंड टू बी द स्मॉलेस्ट.
Yeah.
ठीक है, खत्म. प्लीज गो बैक एंड प्रैक्टिस दिस.
ठीक है.
Please
Yeah.
practice photoelectric effect and come with your doubts now. This
Okay.
chapter is over.
हाँ. Over.
Yes,
Oh.
chapter is over. जी, मैंने आपको बताया नहीं था, मैं I'll finish it in 2 class.
Oh. अच्छा.
So please go
ठीक है.
and do your ma'am assignment, etc., etc., and
Yes. ठीक
come
है.
back with your
Yeah.
difficulties. So next chapter, you let me know what you want to start.
Okay.
ठीक है? Please go
हाँ.
back and revise this. We
हम्म.
can do that chapter, atoms also,
अच्छा.
and then we have to do nuclei.
Okay.
Very
ठीक
small
है.
chapters again.
अच्छा.
Maximum 3 classes each chapter and finish.